Hey, this is Mr. Alfonso. After being sick for the past couple of days, I'm finally back. Today I'll be doing a video lecture on enzymes. So these are your essential questions for the day. 1. Why does lowering the activation energy speed up reactions? 2. What does the word optimum mean? And 3. What does denature mean and what causes it? You'll be able to answer all these questions by the end of the lesson today. So number 1. The first thing you need to know about enzymes are 6 things, okay? You need to memorize them. You will not only see them on your formal quiz, but also on the final. 1. Enzymes are proteins, and they end in ase. You need to know enzymes are the organic molecule protein. That also means they're made of amino acids. 2. Enzymes will always speed up reactions. That makes our lives a lot easier. 3. Enzymes are specific, just like a key. We'll talk more about that later. Number 4, enzymes are reusable because they don't break after use, just like a key, right? Number 5, enzymes like optimum environments, and that word optimum means the best. And 6, enzymes can't denature. Now you need to remember all these 6 things about enzymes. Now the first thing, we'll cover this more in detail, but enzymes are made of proteins. And proteins have the monomer what? That's correct, amino acids. So since enzymes are proteins, enzymes are also made of amino acids, because amino acids make protein. Now, knowing this as well, you need to know enzymes are biocatalysts. Now say the word catalysts. All a catalyst is they're basically things that speed up reactions. And an enzyme is just a catalyst we naturally produce. In all honesty, for this lesson, you just need to know enzymes and catalyst mean the same thing, because you will see that word catalyst, and you just need to know that means a reaction was sped up. And finally, enzymes are always going to end in the word ase. So if you use something like protease or lactase, or you can say your name like Alfonso Ace, that means it's going to be an enzyme, and that means it's made of protein. And that also means it's going to speed up a reaction. Okay, moving on. The second thing is how they speed up reactions. Basically what they do is they lower activation energy. Now break down that word. The word activate means to start, and energy is energy. So activation is just the energy you need to start something. In this case, to start a reaction. So for example, let's say you want a ball to roll down a hill. But in order for the ball to roll down the hill, you need to push it up this hill, and that's going to take a great amount of effort. And then there's the reaction, right? It goes down. Now with an enzyme, it makes it a lot easier. An enzyme is going to, 1, decrease that activation energy. So now that hill is a lot smaller. So now you're not putting as much energy to get the reaction that you want. So you just push up that hill. Now it's a lot shorter. It's easier to start that reaction. How I like to see enzymes, like a coupon, right? It lowers, like a coupon lowers the price so that you can buy something. An enzyme lowers the amount of energy you need to start something. Now this is important because enzymes help us break down food and break down materials that just help us survive day to day. Okay? If you have any more questions, please call Mr. Alfonso over to help explain what activation energy is. Alright, so you can see, the red one has no enzymes, the green one has an enzyme. Alright, and here's another example. Number 3, enzymes are specific just like a key. We call enzymes have a lock and key model. So number 1, enzymes enzymes are like the key, because keys are a specific shape. They are meant to fit somewhere specific, and we can use them to either put things together or break things, right? 2, the substrate is just like the lock. It's a target molecule. So the enzyme will connect with the substrate, and the substrate will either break away or get put together. Number 3, the active site. The active site is where the enzyme and the substrate meet. In our analogy here, it's like the keyhole. So basically, enzyme is specific, like a key, and it will always specifically match one substrate, right? A key is made for a lock. And the active site is where they meet. Now, think about it. What happens if the key goes in the wrong hole? Will it unlock it? No. So that's why we call an enzyme just like a key, because the enzyme will only work with a specific substrate, just like how a key works with a specific lock. Okay, and that's I'll talk about the quick science experiment later. Now finally, take a look at an example of this is how it works. The enzyme is that big molecule. The substrate walks in, it fits perfectly with the enzyme, and look, afterwards it breaks. Now let's get to number 4. Enzymes will always be reusable because they don't break after use. Now, you can keep using enzymes over and over again. Just like keys, enzymes will always work unless they break. So I can use it once, twice, 3 times, 4. Honestly, I could keep using it forever. As long as that it's not broken, I can keep using an enzyme to help me lower that activation energy, so that way I can have a speedy reaction that helps my body survive. Right, number 5, enzymes like optimum environments. Now what does that mean? So optimum just means best, right? So the optimum environment for enzymes, it really depends on the enzyme. Some enzymes like a hot temperature or a cold temperature, or somewhere in the middle. It really depends. You have to look at a graph to figure out which is the optimum temperature. Or sometimes they like a specific pH. Some like it acidic, some like it basic, some like it neutral. You have to read the graph. For example, let's look at this one right here. What is the optimal pH here? Now the optimal pH would be the highest point of the graph. In this case, that's 8. And because that number is above 7, that's a base. In fact, it is a weak base. Now here, the optimal temperature of the enzyme is about 40, maybe 38 degrees Celsius. So that's very hot. Again, the optimal temperature here is wherever the graph is at its highest. Again, optimum means best. Now, let's get to the last key, number 6. Enzymes can denature. Now, what does that word denature mean? All it means is when the enzyme breaks because it changes shape, right? Like how a key no longer works if it changes shape, an enzyme will no longer work if it changes shape. And this can happen by 1, if the pH changes, right? If the pH is too acidic, the key will melt, or the enzyme will melt and change shape. Same thing if it's too hot, the enzyme will melt, change shape. And it doesn't always have to be too hot. If it's too cold or if it's too basic, something will denature. This also includes if something's too salty. That's why some animals die when there's too much salt particles inside it. The proteins denature, they break, and now we can't do our reactions anymore. Right? So again, here's an example of denature, a key breaking, right? Now, that brings us to our final lesson. Let me know if you are able to answer this question. At what point on this graph do you think the enzyme denatures? If you think you got it, call Mr. Alfonso over, and if you get it right, he'll give you a treat. If not, then oh well. Okay? So that brings us to the end of our lesson. Go ahead and answer these essential questions in your summary, and that will take us, that's our lesson for the day. Thank you. If you have any more questions, call your teacher over.